What's happening, guys? Arush here, and today we're talking about the pineal gland, the thyroid, parathyroid, and the thymus. So first, let's talk about the pineal gland. The pineal gland is located in the brain, and if you remember, the first, or what we talked about the other day was the hypothalamus, which is right here. See if I can mark that ball right there. Just below the hypothalamus, we have the pituitary gland. Okay. Well, the pineal gland is located posterior to them. Okay, it's this little gland right here. It's real small. And the pineal gland hangs down from the third ventricle. And we briefly talked about the ventricles of the brain, but what they are, they're cavities that have spinal fluid in them, cerebrospinal fluid. And that's what kind of helps the brain stay floating, okay? So the pineal gland hangs from that cavity that has that fluid in there. So it would be about right there, okay? Now, what does the pineal gland do? Well, it secretes a hormone called melatonin. What melatonin does is it regulates our sleep-wake cycle. So when we go outside and we have lots of light, that light actually triggers our pineal gland to secrete less melatonin. When it's nighttime and we don't have a lot of light, that triggers our pineal gland to secrete more melatonin. And that secretion of melatonin helps us feel sleepy. So, if you guys have ever laid awake at night and then grabbed your iPhone or grabbed your iPad because you can't go to sleep, well, that light emitting from your device is actually keeping you awake even further because that artificial light is inhibiting or stopping that production of melatonin, okay? So remember, melatonin helps your sleep-wake cycle, and it's located in the brain. Next, we have the thyroid gland. The thyroid gland is this right here, located right below the larynx on the trachea. Okay, we have these two lobes of the thyroid gland. And it produces two hormones. The first one is thyroid hormone, and the second one is calcitonin. Okay, so first we're going to talk about thyroid hormone. And remember, the thyroid gland is located at the neck. Okay, so thyroid hormone is a huge metabolic hormone. It controls the rate of glucose. It controls the cell activity and how much glucose it's going to burn. And the thyroid hormone contains iodine. This is actually really important. Okay, so to clarify, you'll hear this word thyroxine, and that is T4. And what that is, that's actually what's secreted by the thyroid, okay? The reason why it's called T4 is because it has 4 iodine atoms in there per molecule, okay? T4 goes to the target cells and is converted into see how we can say that? Triiodothyronine, and that is T3 because it has, you guessed it, 3 iodine atoms in there, okay? So T3 is when T4 is converted, okay? Now, why is that important that I mentioned that it has iodine? Well, if we don't have enough iodine in our body or in our diet, then what will happen is the pituitary gland will sense there's not a lot of iodine, okay? We're not making a lot of T4, so that's going to lead to the pituitary gland secreting more thyroid stimulating hormone, because since there's not that T4, that's going to send feedback to the pituitary gland and says, hey, we need more T4. Well, let's secrete more thyroid stimulating hormone. That excess thyroid stimulating hormone from the pituitary gland is going to increase the size of the thyroid. Okay, it's going to cause thyroid enlargement. That enlarged thyroid is called a goiter, okay? And you'll see this, it's like the swelling around the neck, okay? That's a goiter. Now, typically, this isn't very common in Western cultures because we typically have a sufficient amount of iodine in our diet. If you guys have ever looked at a canister of salt, it says iodinized salt. Well, the government adds in iodine, so we don't have this case of goiters, okay? So it's common in everyone's diet. Okay, so thyroid hormone is the first hormone in the thyroid gland. It secretes thyroxine T4. T4 goes to the target cells and is converted into T3. The second hormone that the thyroid gland produces is called calcitonin. And you can tell by the name, calcitonin affects calcium levels. So, calcitonin decreases blood calcium. Okay? So, if there's too much blood calcium, calcitonin will decrease that. How does it do that? Well, it's going to decrease the osteoclasts. And if you remember when we talked about the skeletal system, osteoclasts are bone breakers. They're the cells in the bones that are breaking down bone cells and releasing that calcium into the bloodstream. Okay? Calcitonin is going to increase osteoblasts. And if you remember, the osteoblast is the bone builder. So it's going to literally pull the calcium out of the blood, and the osteoblasts are going to deposit that calcium into the bone cells. Okay? This is an antagonistic to parathyroid hormone. This word right here, I want you to add this note. Antagonistic. Think of that as like an opposite. Okay? Think of an antagonist as like a yin and yang. And next we'll talk about parathyroid hormone. Okay, so you guys will see what that does. Okay, so the parathyroid gland is on the posterior side of the thyroid. Okay, so this is the back side. This is the posterior side of the thyroid. The parathyroid glands are these 4 small little masses on the back side. Okay, those are the parathyroids. Now, they secrete parathyroid hormone. Parathyroid hormone is the exact opposite of calcitonin. So it's going to increase blood calcium. Now try to think. How is it going to increase blood calcium? It's going to do that by increasing osteoclasts, or the bone breakers. Okay, so it's going to pull the calcium out of your bones by using osteoclasts and put that into your bloodstream. Okay. And then it's also going to stimulate the kidneys and the intestines. So the kidneys are going to reabsorb more calcium from the filtrate, and your intestine are also going to absorb more calcium as well. And that calcium reabsorption goes back into the bloodstream. Okay? It's all going back into the blood. Calcitonin does the exact opposite, removes it from the blood. Okay? Okay, and if you look at this diagram, you could put this on pause for a little bit and check it out. As we get higher calcium levels, calcitonin will bring that back down. As the blood levels go back down, parathyroid hormone will remove that from the bone and increase the calcium levels back up. And we have this constant cycle, okay? So you can think of the mechanism. What is the stimulus for this hormone secretion? Would it be hormonal, neural, or humoral? This type of stimulus would be humoral because it is sensing levels in the blood. It's blood levels that's causing this feedback to happen. Okay. Okay, and the very last gland for today and hormone is the thymus. The thymus is located in the upper thorax. I think of it as a little bit superior of the heart and right above it. It's larger in children. There's actually an interesting story on this right here. It's larger in children and it decreases as somebody gets older. I could tell you guys a story about that later. But it produces a hormone called thymosin. Now, what thymosin does, this one's pretty difficult. Thymosin helps to mature T cells. So think about this. The thymus with a T produces thymosin with a T, and that helps to mature T cells. And T cells are a type of immune cell that we're going to talk about probably next week. We'll get into the immune system. Okay? So those cells, they go to the thymus, that secretes thymosin, and that allows the T cells to mature. Okay? And that is it for today, folks. Feel free to put that on pause, rewind it, take the notes, do what you got to do, and make sure to review the notes from Monday as well on the hypothalamus and pituitary. And I'll catch you guys next time. Bye.